DSP instructions is an area that we talked about briefly before, and the fact that they occur in the Cortex M4 and M7 instruction set architectures. So we mentioned the fact that all of the parts have the ability to do, large multiplies and actually fast multiplies. So when we talk about DSP instructions, we're talking about things that go beyond just the ability to multiply and accumulate. The instructions really divide into a couple of areas. The first one is SIMD operation and packing instructions. So SIMD is a neat little acronym that stands for single instruction, multiple data. So when you do that type of operation, because you have 32-bit wide registers, you could actually represent up to 4 8-bit or 2 16-bit data values in a single 32-bit register. And so the SIMD instructions will then do, in the case of 8-bit values, 4 independent add and subtracts in a single cycle, or 2 16-bit add or subtracts in a single cycle. So if your data operations, like for, say, an A to D converter, which are typically below 16 bits, you can actually double your throughput on your operations by taking advantage of these SIMD operations. There are some support instructions as well for then packing and unpacking those values together. So if you have an A to D converter that you're using DMA to bring the values into main memory, you can then load 2 of those values into registers, and then a single instruction will pack them together, which is pretty handy. And then there's corollary instructions for unpacking those after you do the math. The other major area for DSP instructions is around saturation algorithms. So really that comes down to the combination of add and subtract with saturation in a single instruction. All of the Cortex M's have the ability to saturate as an instruction, both signed and unsigned values, but this then combines the operation. So if I add 2 numbers together and there is an overflow, instead of wrapping around, they'll actually cut off and saturate. So again, that increases the throughput of your math operations.